This is a continuation from number 11b, Roman 3. Remember very well that part B, we were given a complex number z as 1 plus root of 3I. And we did Roman 1 and 2. Now Roman 3 says, express the complex number z in the polar form and represent it on an Argand diagram. So the first thing that I'm going to do here is to express it in the polar form, and then I represent it on the Argand diagram. Remember, polar form is separate from the Argand diagram. They are different. Now, when we're expressing it in the polar form, in some cases we call it the modulus argument form. There is a formula for the polar form or the modulus argument form, and the formula is that z equals to r into cos of theta plus I sine of theta. This is the polar form or the modulus argument form. Now, what is theta? We have already got theta in the previous numbers, and since it is the same question, we can use values from other sections to answer questions of other sections. So in Roman 1, we got our magnitude of the complex number as 2. And in this case, our r is the same as the magnitude of the complex number. Therefore, our r is also 2, because r is the modulus or the length of the complex number. In Roman 2, we got our theta as 60 degrees. So we shall use the same theta here as 60 degrees. So you can see that the polar form is actually easy, because what you need to do is to find r, which we did in Roman 1, to find theta, which we also did in Roman 2. So we don't need to find them again since it is the same number. So we simply substitute. Therefore, here we shall have our complex number in the polar form z becomes r. What is r? Our r is the modulus 2 into cosine of theta. What is theta? Theta is 60 degrees plus I sine of theta. The same theta is 60 degrees. And you leave it like this. This is the polar form. When you expand, or when you press the calculator and you get the cosine of 60 and sine of 60, what you are simply doing is you are taking it back to the Cartesian form in which it was given. So this is the modulus argument form. That's why they call it. This is called modulus simply because there is a length, then there is argument, which means there is an angle form. So that is the modulus argument form. So this is the answer for the modulus argument form. We were told to represent it on the Argand diagram, which I did in the previous video, but it was not asked, just that it assists us in finding the argument. So now from here, our complex number z is given as 1 plus root of 3I. Now the Argand diagram of this would be, first of all, you draw the complex plane of the vertical axis and you have the horizontal axis. The vertical axis is what we call the imaginary axis when you are looking at the complex plane. And then the horizontal axis is the real axis in the complex plane. This one is called a complex plane. But if we represent a complex number on it, then it becomes the Argand diagram. So this is our origin O. The real part of this complex number is 1. So 1 must lie on the real axis. Mark anywhere 1, then you mark the corresponding value, -1, approximately the same distance from the origin. And then our imaginary part has root of 3. So you mark anywhere here, positive root of 3 in the question, then you mark the corresponding negative, which is negative root of 3. When you come back to our question, we have positive 1, which is here. We have positive root 3, which is up here. Then you simply find where they meet. They are intersecting somewhere here. You do not need to be very accurate, and even you don't need a graph paper. This is just rough estimate. Then you use a ruler straight line from the origin up to where the complex number is, up to where they meet, Now this line is actually the complex number. You can put an arrow on it anywhere, but mostly they put it on top, showing the direction, but you can put it anywhere. So that is the complex number Z. This is the complex number Z. You can mark it there. That is the complex number Z. What was our argument here? Our argument was 60 degrees. So this is the Argand diagram that was required in Roman 3. And this is the solution to the whole of number 11b and the end of question 11. So as a reminder, this is Vision Plus, and we encourage you to share these resources with your brothers and sisters, with your classmates and friends, such that your learning is enhanced. In case you have questions or concerns, leave them in the comment section, and our team of experts shall respond to you accordingly. Thank you.